Ever wonder how we can get a computer to actually understand language? I don't just mean recognizing words, but really getting the grammar, the rules that glue everything together. Well, today we're diving into this incredibly elegant feature in the Prolog language called definite clause grammars, or DCGs. You could say they're Prolog's secret weapon for finding patterns.
Right, and that's the core question, isn't it? If you want a computer to make sense of anything structured, whether that's a sentence, a data format, or even just a sequence of steps, you have to tell it the rules of the game first. And as we're about to see, DCGs give us this amazingly intuitive way to do just that.
So what's the big deal? Well, DCGs bring a special kind of rule into the Prolog world. It looks almost exactly like a normal rule, but one tiny little change in the syntax, well, it makes all the difference.
Okay, so on the left, you've got your classic Prolog rule. It uses that :- thing, which basically means the head is true if the body is true. Simple enough. But on the right, with a DCG, we use this little arrow, and that arrow, it's like a secret signal. It tells Prolog, hey, we're doing grammar now, and it unlocks a whole different set of powers.
So what exactly is a DCG? Officially, it's just a special way to write down grammar rules. The really cool insight here is that it treats everything as a list. It can take a list of words and check if it's a valid sentence. That's called parsing. Or it can work backward and actually create a valid sentence for you from the rules. It's a two-way street, which is just incredibly powerful.
All right, so that little arrow is pretty neat. But how does it actually work? I mean, the simple syntax is great, but you just know it's hiding some serious machinery just below the surface. So let's pop the hood and take a look. And here it is. This quote from the SWI Prolog documentation basically gives the secret away. DCGs are a comfortable interface for something called difference lists. Think of it like this. The simple grammar rule is the slick, user-friendly dashboard, and difference lists are the high-performance engine running in the background.
So that just leads to the next question, right? What in the world are difference lists? And what's this magic trick that turns our simple little arrow rule into something so capable?
Here's the trick. DCGs are what programmers call syntactic sugar. It's a fancy way of saying it's a shortcut. You, the programmer, get to write these simple, clean, easy-to-read rules. Then, behind the scenes, Prolog automatically rewrites them into more complex but super efficient standard code that handles all the messy bits of list processing for you. You get the clarity, the computer gets the power.
And here's exactly what that translation looks like. We write the super simple thing on the left. A sentence S is a noun phrase NP followed by a verb phrase VP. Prolog sees that arrow and rewrites it into the code on the right. See those extra variables? The S0, S1, and S? That's the magic. Think of S0 as the whole sentence you start with. The noun phrase rule NP chews off the first part, and what's left over is S1. Then, S1 gets passed to the verb phrase rule VP, which does its thing and leaves a final remainder, S. It's like this invisible thread passing the list through the rules. It's brilliant, really.
So now that we see the mechanism, let's talk about what people use it for the most: parsing. This is all about taking a stream of symbols, like words or characters, and finding the hidden structure within them.
Let's look at a real example. This rule defines what an integer is. It says an integer is made of one or more digits. But then look at that bit in the curly braces. That's a special escape hatch that lets you run normal Prolog code. So after it finds a list of digit codes like 4 and 2, it uses that helper to turn them into the actual number 42 and saves it in that variable I.
So to actually run this thing, we use a built-in command called phrase. We're asking Prolog, hey, can you use my integer rule on the string 42 times? And if you find an integer, put it in X and tell me what's left over in rest.
And look at that, it just works. Prolog comes back and says, yep, X is 42 and the rest of the string is times. It's like it perfectly carved out the piece of the string that matched our grammar rule.
Okay, but natural language is rarely that clean. It's messy, it's complicated, and a lot of the time it's ambiguous. Take this classic sentence. I saw her duck. What does that even mean? Well, it turns out it can be understood in two totally different ways. How can a grammar deal with that?
So in the first interpretation, her is possessive, and duck is a noun. I saw the waterfowl, the animal, that belongs to her. A DCG can totally find this grammatical structure. But here's the cool part. Thanks to the Prolog engine, it doesn't just stop there. Because of a feature called backtracking, Prolog can automatically go back and look for other possible answers. And it finds this second structure, where her is an object and duck is a verb. As in, I saw her perform the action of ducking. A well-written DCG will find both of these valid interpretations for you, all on its own, effortlessly.
Now, it's really tempting to think that DCGs are only for parsing natural language. And while they're amazing at that, it's really just scratching the surface. They're a general-purpose tool for dealing with any kind of sequence or state. So when should you actually reach for a DCG? Well, the Prolog expert Marcus Triska gives us some great rules of thumb. Use them anytime you're describing a list, reading something from a file, or, and this is the most powerful one, anytime you need to pass some kind of state from one step to the next. That last one, what he calls an accumulator, is exactly what those hidden arguments were doing for us.
And check this out. This is a real example from a library in SWI Prolog. This DCG is not parsing text. It's not about language at all. It's building a list of system statistics. Each one of those items is a separate operation that finds some data and adds it to a growing list that's being passed along invisibly in the background.
This is that accumulator pattern in action. The DCG syntax just gives us this really clean, linear way to thread some state, in this case our list of stats, from one operation to the next. It's a completely different way to think about what a grammar can even be.
And all of this, it really brings us to the final and maybe the most important takeaway. The reason DCGs are so powerful is because they're a perfect reflection of the whole philosophy behind Prolog itself, what we call the declarative advantage. This quote just nails it. With a declarative language like Prolog, your job isn't to write out a detailed step-by-step recipe of how to solve a problem. Your job is to simply describe what the problem is, the facts, the rules, the grammar. You describe the world, and then you let the system's logic engine figure out how to find a solution.
And really, that's the thought I want to leave you with. How would your own way of thinking about problems change if you didn't have to worry about the messy, step-by-step mechanics? If you could just focus on describing the what instead of the how? That right there is the power and the promise of tools like definite clause grammars.